I have a few questions, but to start with, if you don't mind, kind of introduce yourself and tell us a little bit about what you do.
My name is Matt Pickett. I'm a contractor. I work for a company called M4 Consulting. And my primary client these days is NOAA, the National Oceanic and Atmospheric Administration, working with unmanned technologies, primarily unmanned aircraft systems, to help NOAA kind of develop the procedures and protocols for using those type of systems for biological monitoring, living marine resource surveys, habitat mapping, and so on.
And you've been using UAVs to try to to look at some seabirds and understand their behavior?
Yes, we've done a couple of projects with seabirds. Recently, we were working with Oregon State University and Oceans Unmanned, a nonprofit, to try to find these marbled murrelets that nest in old growth forest up there.
Why is it important to find these seabirds?
Well, the marbled murrelets are an endangered or a protected species, and they've been relatively unknown, kind of their habitat. The first nest wasn't really even discovered until 1974, which is extremely recent for a species that prominent. And the main reason they're kind of important, both politically and financially, is because they do nest in the old growth forest. And the logging pressure, as you know well, in Oregon and Washington is a huge industry. So if researchers can identify the habitat and the forest stands that they use to nest, that can allow the logging to not impact those areas and allow that to still continue in an environmentally safe manner.
Okay. And what sort of systems are you using? I understand you're using commercial off-the-shelf products.
Yes, original field survey, we took 4 different systems up there. We took a Phantom 2, DJI Inspire, a Phantom 4, and then a Microdrones MD4 1000, which is a bigger quadcopter system. We evaluated all 4 of those platforms, and the Phantom 4, the DJI Phantom 4, became our go-to tool during that evaluation period. It was just small enough and nimble enough to fly under the canopy. We had some ideas originally that perhaps we could fly above the canopy and use infrared to see where the nests were and then kind of focus that way. But the canopy above the nest is too thick to do that. So we ended up having to fly under the canopy.
Okay. So that kind of leads into the next question. What sort of performance do you require from a UAV to be useful for this kind of thing?
Small and nimble and relatively stable. The Phantom 4, once you get GPS lock, it just rocks solid, and it's small and nimble enough that you can fly among the branches and within the tree relatively easily and feel confident that you would maintain control of the platform the entire flight.
And what sort of sensors are you using on these?
So we were using the stock Phantom 4 camera for visual orientation for the pilot, and also to compare that data with the FLIR unit. We attached a FLIR View Pro to the Phantom 4 so we could collect simultaneous IR and the visual imagery. And so the FLIR View Pro, small, that we use a higher resolution version to get the resolution we needed to actually spot the birds. So.
Is that the easiest way to spot them, using the infrared versus?
Yes, if you come to our presentation at AUVSI in Dallas, you'll see some pretty amazing slides where we put up side by side what you see or really don't see visually, and then with the infrared overlay, how easy it is to see those birds hidden in the trees.
So how are you enabling this sort of precision flying into the canopy? Is it just a really skilled pilot, or programming things in? Or?
I don't want to give my pilot too big of a head, but yes, he was very skilled. He was actually a NOAA pilot for years and years and has a lot of experience. One of the challenges in the canopy was to ensure we got GPS lock before we launched, and occasionally we couldn't do that. So we would have to launch, kind of fly above the canopy or find a gap and stay airborne until we got GPS lock, and then begin the survey of the tree. We wouldn't fly a survey unless we had that GPS lock. And we had 2 observers helping the pilot at all time, because you're basically kind of, flying a 3-dimensional Frogger, where it's like, okay, you can go up 10 feet, move over, 3 feet. All right, I think you can continue up. So between 2 observers using that camera as a visual reference point to fly through, we were able to fly safely the whole time and never had any incident. So.
And so I assume that people at Exponential will hear more about this as well, but what kind of potential have you seen being able to find and understand these birds a little better using this technology?
Well, we've had 2 kind of interim steps so far, where the first time we went up there, we actually flew at the Newport Aquarium, where they have an aviary, and that there's a net. And so we flew outside above the aviary just to make sure we could image seabirds with an IR sensor on a UAS. Then the next time we went up there, we used quail as a stand-in for the marbled murrelets, where the researchers would go in ahead of the UAS team, hide the quail in the trees in cages, and then we had to go in and try to find those hidden quail, and we were able to successfully find 10 out of 10 without knowing where they were. Since we proved the concept, we're going back up in June and late May and early June to actually work during the nesting season with marbled murrelets. We had to prove the concept so we could get the permits to actually work in the forest during nesting season. So when we go up there, we're either going to succeed, or the marbled murrelets are going to be different enough from the quail that we'll have to go back to the drawing board. But the potential is there. I mean, the infrared on UAS is an amazing combination that's really working out well, not just for birds, for other species that we've been researching as well.
And tell us a little bit more about these birds. Where are they typically located and how do they behave?
So what's interesting about the murrelets is they spend most of their life out sea, feeding at sea, and then when they come into nest, they nest in old growth forest, 200 feet off the forest floor, in these 300-foot tall trees. So they're way up there, well hidden from predators. They can nest anywhere from old growth forest just a few miles off the coast to up to like 100 miles inland. So it's a huge area that they have to kind of survey to try to find these birds, and they can work all summer long and perhaps find only 10 nests, because it's such an effort to try to track these birds and find out where they are. So if we can use UAS to even find a few each season, we've dramatically increased the efficiency of their tagging and tracking operation.
And so, based on what you've done so far in terms of looking for these other birds, what improvements would you like to see in these unmanned aircraft that you're going to be using?
I think taking some of the stress off the operator and going to fully autonomous, and we actually have a partnership with UC Santa Barbara, University of California, Santa Barbara, where some of their engineering students are trying to adapt a fully autonomous kind of scanning system, where you can launch the UAS, it can scan 365 in its environment, and then you just target a tree and it will automatically do kind of that back and forth scan up and down the tree, and take that kind of stress and pressure off the pilot kind of flying visually and manually. So I think higher resolution FLIRs are always nicer, even they're not close to HD right now, but they're really good. So I think the resolution of the FLIR unit will continue to improve. If we ever got to fully autonomous surveys where you could just program in the tree to survey and it would take care of itself and avoid obstacles, I think that would be very powerful.
So tell us a little bit more about what you're going to be doing when you go and actually fly looking for these birds. How many flights are you going to try to do? How long a period are you going to be out there?
We're scheduled to be up there for 2 one-week periods because they're not exactly sure the peak of the nesting season. And the UAS survey is kind of the tail end of a big field season where they go out in a boat, they capture these birds at night, they put a little radio collar on them, and then they stand on the beach, and when they start coming in, they get pings as they fly over the beach. And then they hire an aircraft and the aircraft goes and does broad area service to try to get generalized ping location. Then they send researchers out with hand radio signals at receivers and try to narrow it down. And then only then does the UAS crew come and try to search that area and find the birds in the nest. So it's a big effort, and the UAS is only one small part at the tail end to try to kind of refine the location of the nest once we have a general location.
Okay. And based on using the infrared, could you foresee using it for some other things in the future beyond?
Yes, we just got back this past week from a project out in the Channel Islands off California, using infrared to look for sea otters in the kelp forest, and then elephant seals on the beach. And the results are fantastic. And that seems to be, a really powerful combination for UAS for living marine resources, where you have a dual payload of an infrared and a visual camera, because a lot of animals are well hidden or camouflaged, and having that infrared really makes it easy to locate and identify them. As far as moving forward, we have a lot of other interesting projects planned in the summer and fall, but you're going to have to come to AUVSI in Dallas and watch our presentation to hear more about all that stuff.
Very nice. All right, well, that's kind of all our questions. Is there anything that we didn't get into that we should understand more about this?
No, I don't, like I said, I don't want to give away too much for the presentation. So I think that's the highlights and the concept.
Great. Well, thank you very much for your time.